So in this session, we are going to start with the behavioral modeling type of abstraction. Okay. So in our previous sessions, we have completed with the gate level model of extraction, and with this particular session, we are going to start with the behavioral model of extraction. So basically, in the behavioral modeling, it is the highest level of abstraction, focusing on what the circuit does rather than how it is constructed. So basically, in the gate level modeling, we were focusing on the internal structure of the particular design. So we were seeing how many gates are there and what type of gates are present, like XOR gate or OR gate or AND gate. So we were focusing on the structure and focusing on the type of gates. Okay, but in the case of behavioral modeling, we are not concerned regarding the internal structure or what type of gates we are going to use. Okay, so in the case of behavioral type of abstraction, we are only going to focus upon the behavior of a particular circuit. We are only going to focus on the behavior of a particular design, or you can say circuit. We are not concerned regarding what type of circuitry it is, what type of gates we are using, nothing. Okay. So a designer who is using this particular behavioral modeling does not have any knowledge of internal circuitry also. No issue. If we just knows the behavior of a particular design, just he can start coding and doing that particular design. So is this clear? The intro to the behavioral modeling is clear for everyone. So it allows designers to describe the functionality of the system in terms of algorithms and high-level control structures, much like in writing as a software program. Just now I have told you, right? So we are not concerned regarding the internal circuitry or internal gates. That's it. Okay. So we are just writing the code like an algorithm. Okay. Or just we are only concerned about the particular behavior of a particular design. Okay, yeah. So that was about introduction to behavioral modeling, and this modeling style is particularly useful during the early stages of design, enabling quick development and functional verification before moving to lower level abstraction levels such as data flow or gate level modeling. Like if you have a particular design requirement, if you have a particular requirement to achieve something, okay, like if some specification is given to you, so you are going to focus on the behavior of a particular circuit. You are going to write the behavior of a particular circuit using this behavioral modeling. Okay, so you are going to write your Verilog code using this behavioral modeling, and you are going to check whether the functionality is the functionality what it is expected, and the code, okay, the functionality what you're getting is correct or not. Okay, so you are going to verify your functionality. You are going to verify your functionality by writing this particular code in the behavioral abstraction. So if it is matching, then you are going to another levels like gate level modeling, so that you can be more precise. Your design can be more precise in terms of delays or in terms of number of gates. Okay, in terms of latency, you can be more precise if you want. If your specification requires that much of preciseness, you can go for another low level of abstractions also. Okay, so that is where the behavioral modeling can be used. Yeah, so this was the introduction to your behavioral modeling of abstraction. Now, initial block as well as always block. So these are my structured procedures in my Verilog. Okay, so let us try to analyze what is meant by the structured procedures. Now, so before going to discuss what is meant by the structured procedures, let us try to analyze. Like for example, in the case of C language, let's say in the case of C language, if you write some code, okay, so if you write some 4 lines or 5 lines of code, tell me whether this code is going to execute sequentially, that is line by line, or it is going to execute parallelly, that is all at once. Whether it is going to follow a sequential flow of execution, that is one after the another, or it is going to execute parallelly. All the lines of codes will be executed parallelly. In the case of C language, anyone has this idea regarding this? Sequential language, the lines of codes, so these are going to execute sequentially, not parallelly. Okay, so C language is a sequential language. But coming to Verilog, coming to Verilog, it is a concurrent language. It is a concurrent language. What is meant by concurrent language? Concurrent means it is a parallel language. Okay, so the execution here in the case of Verilog takes place parallelly. That is, that is Verilog follows the concurrent flow of execution. Okay, so in the case of Verilog, every statement will be executed concurrently, or the Verilog is going to follow a concurrent flow of execution. Is it clear? So let's say if we have a module name and declarations, we have done some declarations here. Now, so after doing this particular declarations, let's say if we have written something, what we have discussed recently, gate level modeling we have discussed, right? So and gate something we have written, or gate we have something written, XOR gate we have written something, followed by end module. Now tell me which of the following will be executed first, and or XOR. Which line will be executed first?
And
Say if we have a module followed by module name followed by some declarations followed by procedural statements. Now only we have seen, right, what are the structured procedures or procedural statements. We have initial block as well as always block. Okay, initial block as well as always block inside the same module. Now tell me which block will be executed first, whether initial block will be executed first or always block will be executed first.
Both at same time.
So do remember, I have told you Verilog is a concurrent language. So both initial block as well as always block will start their execution at time t is equal to 0 time units. So at time t is equal to 0, both initial block as well as always block starts their execution. Okay, so both these blocks will run parallelly, or you can say concurrently. Okay, so is this clear? Please do remember this. This is a very important point. Both the blocks will be running parallelly and both will start their execution at the same time. Okay, I'm telling both the blocks will start their execution at same time at t is equal to 0. If we have uh, two always blocks, if we have two always blocks inside our design, so what happens, this two always blocks will also start their execution at time t is equal to 0. Okay, and if we have two initial blocks inside our design, these two initial blocks will also start their execution at t is equal to 0, and these two initial blocks will also run concurrently. Okay, concurrent to each other, they run parallelly. Okay, so there is no order of execution, though these two blocks will run parallelly. Not only two blocks, any number of blocks which are present inside the module, they will run parallelly. Okay, now, so we have seen a term which is known as structured procedures. These are also known as sequential procedures or sequential blocks also, you can say sequential blocks. So what are these structured procedures or sequential blocks? First one is initial and second one is always. Let's discuss one by one. Let's start with our initial block. So the syntax for initial block is the keyword initial. If you have only one line, then you can simply write initial followed by one line of execution followed by, just you can leave it simply. But if you have multiple lines inside your initial block, you should write initial, begin, multiple lines of codes, and end. Is it clear? So if you have multiple lines of codes, you should use begin, end, and if you have only one line, there is no need of begin, end. Is it clear for everyone?
Yes, sir.
Yes. Now, now the second rule is, let's say a is equal to 0. So inside this initial block, what I am writing, the first line of code, a is equal to 0, b is equal to 1, c is equal to d, something I'm writing. Okay, now tell me, so this is my LHS, so this is my LHS, and this is my RHS side. Okay, so the rule is LHS side variables should be only of reg data type. Okay, the LHS should be of only reg data type, and RHS can be of reg and wire. Is it clear for everyone?
Yes, sir.
Reg or wire or some constants, you can say, or integers. Okay, any data type. There is no restriction on the right hand side. So let me write some code. Module ex input a comma b, output c comma d. Okay, initial c is equal to a, d is equal to b, and module. So whether this will be executed, so whether this code will be executed or it will be successfully compiled, yes or no. If no, why? In this particular example, if we observe C and D, we are not mentioning them as reg data type. So by default, they will it will be of only net data type. Okay, so by default, it will be of only net data type. So on the LHS side, you cannot use net data type, so you will get a compilation error. And there is one more compilation error. What error you may get? Multiple lines, so begin end is not used, so you will get a error, syntax error here. Okay, so is it clear for everyone? Now if we write this initial begin end block, so the behavior of this initial begin end block is like, so it will start at time t is equal to 0. So this initial block will start at time t is equal to 0, and it will complete all the executions which are present, or it will complete all the assignment executions which are present inside this initial begin end block, and it will come out of this initial begin end block and simulation gets end. Okay, so basically this initial begin end block will execute only once, will execute only once. Is it clear? So this initial beginning block will execute only once in a simulation period. Okay, so if all the statements, all the assignments which are declared inside this initial beginning block, okay, so after that the simulation gets end. Okay, it will not again restart. So that was my 2 points. So on the LHS side, I should use my only reg data type, and I should use begin end if I am using multiple lines of codes. And my initial block will start at time t is equal to 0, and it will only run for only once. Okay. Now, so outside my initial block, everything was running concurrently. Okay, but inside my initial block, okay, inside my initial block, the statements will execute sequentially. It will execute sequentially. Okay, that is, after completion of first statement, it is going to execute next statement, and after that the third statement. Okay, so there is a sequential flow of execution, or you can also say it is a procedural flow. So you can say procedural flow, or it is a sequential flow of execution. So that's why these blocks are known as sequential structured procedures. Okay, so you can say it is a procedural flow, sequential flow. So this initial block and always block are known as structured procedures. So inside a initial block, the statements will get executed sequentially, that is one by one, not parallelly. Okay, sequentially they are going to get executed. Yes, inside this initial block, the statements will execute one by one. That is, First C is equal to A will be executed. Next D is equal to B will be executed. Okay, like the C language, the procedural flow, like first statement will be executed, then after the next statement will be executed. First C is equal to A will be executed, next D is equal to B will be executed. Like that, the sequential flow of execution will take place. And the initial block will start at t is equal to 0 time unit, and after completing all the executions, all the assignment execution present inside the initial block, then only it is going to end, the simulation is going to end. Let's say if we have initial a is equal to 0 and initial b is equal to 1. Now tell me which block will start its execution first.
Both at same time, sir.
Yes, okay, both at same time. Now let's say if I write a is equal to 1 here. Now what will be the value of a if we display that? So if we write like this, initial a is equal to 0, initial a is equal to 1. So these two statements will start their execution at the same time, and the compiler will throw a unknown value to a. Since these two executions we are trying to drive 0 as well as 1 at the same time, so it will be equal to unknown. A will be equal to unknown. We will not get a compilation error, we will get a unknown value here.
Yes, sir.
Now, so this was about initial block. We will come back to initial block again. Okay, so this was a brief intro about initial blocks. Still we have blocking statements, non-blocking statements, delays. Okay, and we have still some more concepts. Now we will come back to it. Okay, now let us discuss about always block. Same for this always block also. We should use begin followed by end. Okay, begin followed by end. Now, so inside always block, it is also going to follow a sequential flow of execution. It is also going to follow a sequential flow of execution. And if you write always begin end, this always block is also going to start at time t is equal to 0 time units, and it is going to run forever until the simulation ends. So this always block will going to run forever until the simulation is going to end. So that is why the name itself indicates always. Okay, always begin end. So it is going to run forever until the simulation is going to end. Is it clear? The always block, is it clear? Now, so inside a always block, we have a concept called sensitivity list. Okay, so we have a concept called sensitivity list. I'll write it here. So let's say if we have a design like this, and these are my inputs A, B, and this is my output Y. Okay, now I can model this design using an always block, always at the rate A comma B, Y is equal to A plus B. Okay, so here at the rate A comma B, this is my sensitivity list. Okay, so this is my sensitivity list. So what is meant by sensitivity list? So inside this sensitivity list, whatever variables we have declared, so if there is any change in the variables, so if there is any change in the value of A, or if there is any change in the value of B, okay, so this particular always block will be triggered and it will be executed. Let's say suppose if A value initially it was 0 and it is going to change to 1, then this always block will gets triggered and it will be executed. Okay, and if there is a change in B, okay, from 0 to 1, then only this always block is going to get triggered. So this always block will only get executed if there is only change in the sensitivity list. Okay, so unless unless and until if there is any change in the sensitivity list, the always block is not going to triggered or get executed. Okay, so like this particular sensitivity list works. Okay, so if you want to model any combinational circuit, so what is meant by combinational circuit? Can anyone so in this full adder, this is our output sum, and this is our output carry. Let's say x and y carry. Okay, and these are my a, b, c. Okay, so whenever there is any change in the input values, then only our output is going to get. Okay, so then only we are going to get any output. Okay, so basically to model this combinational circuits, we can use this procedural statements like always block. Okay, so how can we model this? Always at the rate a comma b comma c. That is, if there is any change in a or change in b or change in c or both three, this always block will be triggered and it will start execution. The logic inside this will be executed sequentially. Is it clear? Is it clear for everyone?
Yes, sir.
Yes. So same rules apply. On the left hand side, we should use only register data type, and on the right hand side, we can use any data type. Okay, same rules apply here. Now, so if we have reg A, B, C, D, uh, comma E. Okay, always at the rate of E, B is equal to 1, C is equal to 0, D is equal to 1. And okay, and by using my test bench, or somehow I'm changing my values of A from 0 to 1, B from 1 to 0, and C from 1 to 1 only. Now, so what? Sorry, 1 minute. Reg A, B, C, X, Y, Z. Let's take like this. Always at the rate E, begin. A is equal to 1, B is equal to 0, C is equal to 1. And so, what will be my display statement value of A, B, C? What values will I get for A, B, and C? What I am writing? Always at the rate E, begin. A is equal to 1, B is equal to 0, C is equal to 1. If I display this particular statement, then what will I get displayed? The values of A, B, and C. Yes. Okay. So inside the sensitivity list, yes. Because there is no change in E, that particular always block will not get triggered. Okay. So that's why this particular always block will not get executed. Okay. So this was a brief intro about the always block and initial blocks in behavioral modeling. Okay. So we are going to discuss more about this always block and initial block in detail in our upcoming sessions. Okay. Yeah. So that's all for this session. So if you are having any doubts or queries, you can ask me, or else we can end this session.